Okay, I'll close the slide deck here and we will get going. Hello and welcome, folks. I'm Kai Nagata and I'm the Communications Director at Dogwood. I'm speaking to you today from Gigajoule territory in northern BC, and joining me today is Rider Petch. Rider, do you want to introduce yourself?
Yeah, hi there, and thanks for joining, everybody. Thanks, Kai. I'm an energy consultant with Fluent Energy Consulting, and I'm certified by Natural Resource Canada as an energy advisor. So yeah, I'm here to basically talk a little bit about delivering the Energuide efficiency, home efficiency program, which is pretty cool.
Okay, great. So this is our fourth workshop in the Decarbonize BC series. And so far we've talked about efforts to resist oil and gas expansion on the ground, but also get fossil fuels out of our daily lives. So today we're going to get as hands-on as we can over Zoom and talk about home retrofits, how to upgrade your home so it's running as efficiently as possible, saving you money and polluting less. And Rider's going to be our guide. So he'll share some tips and tools as well as rebates. There's a big one that expires next week, so you want to know about that one. And we'll leave lots of time for your questions at the end. So throughout the workshop, you can add your questions to the Q&A section on Zoom, and you can give a thumbs up to other people's questions to bump them up the list if you have the same question as them. And if you do run into any technical difficulties, just make sure to use the Zoom chat window, and Jamie will do her best to respond. Thank you, Jamie, for running the Zoom platform today. And so as we get going, I want to put a little survey up on the screen just to get a sense of where you're focusing as you think about your home and your home retrofit journey. So we'll bring the survey up, we'll leave it up for a few minutes, and you can go ahead and pop in your answer and click on as many of those options as you like, just so we get a sense of where folks are coming from and what you're focused on as you start to think about home retrofits. So Rider, like any project, you got to know where you're starting from, right? You got to be able to measure your progress. So in Canada, we have the Energuide program and Energuide home evaluations. Can you tell me what happens when I book an Energuide home evaluation?
You betcha, Kai. So with the Energuide rating system, which is administered by Natural Resource Canada, the goal is to rate the energy performance of homes. So we have a lot of homes out there. We don't really know what's going on. So it's a great program just essentially to build some energy literacy and provide some performance information on the existing housing stock and just help support people to better operate and renovate their homes in some cases. So we look at you look at energy performance, obviously, throughout the home. We look at factors for comfort, for health, how the house is set up, and to reduce the environmental impacts of the house itself, which typically involves reducing your greenhouse gases associated with the operation of that house. So when someone is looking for an energy assessment, they have an energy advisor in. Energy advisor is in. We look at essentially the building envelope, how it's set up. I mean, those kind of give us an idea of the building losses, the energy losses. We also have a look and we get an idea of the mechanical systems in the house to have an idea of just how much energy the house is using. So we want to know where the losses are occurring and how much energy is being used. So that's the very big first step of this program is getting an energy advisor into your house and trying to figure out where does my house sit on this continuum of in the big picture of energy use and in how it kind of environmental impacts it has.
Right, and then you prepare something. You prepare a report, basically, like a one sheet at the end that the person can look at to get a glance of basically how much energy they're using and what the GHG impacts are. Let me bring up the actual Energuide report here. So can you describe what we're looking at here?
Yeah, one sec. I'll just I've got a poll in front of me, so I'll just pull that down so I can actually see what we're looking at here.
Sorry, I think I minimized that too quickly before people could.
No, that's all good. Okay. No, this is a pretty crazy label. If you imagine when you go into the department stores to buy an appliance, this is a similar kind of rating system where you have a label now for your house. And this is actually an amazing brand new label that's come out in the last few years. It's very detailed. And so the key, you glaze over when you see all this information, but what you want to do is look at that big number at the top, that 170 you see there in the center. That's the gigajoules used per year that this house uses. And then below it, a typical house, it says 109 gigajoules. So it would say that if your house is producing that much in relation to a house built in that region, typically a new house, so you can get a sense of where your house sits. In this case, it's pretty high, 170 gigajoules per year in relation to a standard new typical house built to code that is similar to the style of house you have. So it gives you a nice little look on a big sort of picture of just where you fit on that whole energy use cycle. So it's, as you can see, the left on that colored bar is 0 gigajoules of use, getting towards the net zero houses. And then on the red side, they're using the most energy. So your goal here is to move that dial to the left on your energy use.
Okay. So just to pause for a second, gigajoules. I don't know if most of us are used to measuring our lives in gigajoules. What is a gigajoule?
Yeah, so gigajoule. I definitely. It sounds like something on the Jetsons, or something you'd see 7 parsecs away in another solar system. But yeah, the gigajoule is approximately 278 kilowatt hours. So you can kind of look at, this is actually a nice little diagram from Natural Resource Canada. It says you could toast 3,000 bagels with 1 gigajoule. I'm sure a lot of you called in today to know if they could cook that many bagels, but that's what it would take. Another more useful one might be running a typical refrigerator, as I said, for 30 weeks or 7 months. So you kind of, probably a propane tank is a 0.5 gigajoule for your barbecue. So it's actually a fair amount of juice depending on what's running. So, and there's also the person at the top who could vacuum for 230 hours straight on that gigajoule if they were really so entitled to do so.
So we're looking at a diagram of sort of a cartoon house. There's people in different rooms running different appliances and things. And it gives you a sense of how much energy you're using with, like you said, 1 barbecue tank's worth of energy. So that would be like a 20-pound barbecue tank. And if that's electricity, you could surf the web for 5,500 hours, vacuum your house for 230 hours, toast 3,000 bagels, watch a lot of television. This is kind of like deranged. I don't know. I look at the people in this house and it's like, who wants to spend 230 hours a year vacuuming? But it gives you a sense of just how much energy we use in our lives, because that's 1 gigajoule. And then what do you find as the average use in BC? Like how much energy are people actually using in a year?
Yeah, so part of this whole using these terms is getting a little bit comfortable and literate with what they mean. So yeah, Natural Resource Canada says like the average use is about 100 gigajoules for a house in Canada. And it really varies. If I can provide a spectrum, I was at a house, an older house, probably early 80s, 3,000 square feet on an old inefficient natural gas system, about 150 gigajoules used, a little better than that. I've been to another, let's say, going on the exact opposite, step 5, which is 50 to 80% more efficient step code kind of house. I'll get into the step code stuff later, but and that's with on an all electric system, and that's about 40 gigajoules. So you could see the range of efficiency there, 40 to 150. Median's about, like as I said, about 100 gigajoules. So that's where you sit. It kind of depends on your house size and systems you use and how much your house is losing for energy. So,
right.
Yeah.
So we're going to get into the conversation about switching out appliances and efficiency, but I think as we look at the overall picture of households in BC, I mean, one thing that's clear to me is that all of this would be easier if we used less energy, right? Like if we're talking about switching over from fossil fuel systems to electricity, and then we're thinking about how do we generate that? Where does it come from? What does it cost? I mean, all of these things, the whole conversation just gets simpler if society as a whole finds ways to use less energy. And frankly, we use energy in a lot of really inefficient and downright selfish ways. Toasting 3,000 bagels at a time, for example. Nobody needs that many bagels. I wanted to get back to that. 3,000 a year. That would be like almost 10 a day. So getting back to the inner guide one sheet, there's a number on there that's really important. I wanted you to talk about that. So it also includes your energy intensity, and it includes your greenhouse gas emissions, because based on where you're getting that energy from and how much you're using, you can calculate how much greenhouse gas pollution your house is creating every year. So can you tell us about that line and again, what's typical for a house in BC?
Yeah, this is a pretty significant piece of information now. Essentially, this, that what's circled there, rated greenhouse gas emissions, 10.4 tons per year. That's how much this house is, that's how much carbon pollution essentially this house is delivering. The label now that Natural Resource Canada established is great. It's got this great information on it. You're getting your energy use, and now you're getting an understanding of the type of footprint this house has climatically. So it's not, it is kind of an amazing development on an information level. Basically, you'll know now when you go to look at a house, you can say, you can ask to see the label. These are new houses, and as old houses get brought in to get these evaluations done, more houses will have these. You'll know what kind of house you're buying into. How efficient are you buying into of a house? Are you buying an energy lemon? Or are you buying an elegant kind of a swan here that uses not much? And as for the GHGs, you can look on the list label now right up front and know how much your house is polluting. So it's really, I find empowering to have this information now right at our fingertips. Like, exactly right on the front of your house what you're getting into. And there's very, very good ways to look at that number and bring it down. All sorts of options depending on what you're starting with. So that's sort of a really important thing to know about your house now, is that this is all up front. There's going to be no mystery how much a house pollutes or how much energy it uses. These labels are very informative. So big development there.
That is a significant number, because, if you look at what scientists say we need to, where we need to bring our sort of carbon footprint at an individual level in order to bring emissions down and have a good chance of preserving our civilization over the next century or so, it's like around 2 tons per person per year. I mean, if you look at the global picture. And so when our houses on their own are creating, in this case, 10.4 tons, it's going to be difficult to hit those targets so long as we are creating a whole bunch of emissions just from living our lives. I mean, that's before you even get in your car and go to work. So yeah, 2 million households in BC, give or take, and 6 out of 10 are hooked up to a gas pipeline. So that's over 4 million tons a year that we're cranking out just from houses. What is the province doing right now to bring that number down?
Yeah, there's some pretty exciting stuff right now. I think everyone is on board with the fact that we have got a carbon constrained society now, and we need action. Clean BC is set up, has the support of both of our utilities. Both are highly motivated to figure out ways with their existing systems to reduce their carbon intensity. So each utility is pulling different levers to help their own systems. They're all collaboratively working together to a common good, which is what we all need to be at. There was a time in history when, people didn't really believe in what we needed to do here, and it's an exciting time because I think we're all united in agreeing that we have to get our carbon use down. So right now, if you aren't aware, you want to be going to check out Clean BC's website. They have both BC Hydro and Fortis have presented all sorts of interesting rebates for new homes and for existing homes, and they're very different packages and rebates depending on where you are. And there's different approaches, and I'll talk about that later, about what you want to do with an existing home as your priority to reduce your carbon and decarbonize versus what you do with a new home. It's actually, they're related, but there's some significant differences in the approaches, and we can get into that later as well.
Okay.
But yeah, basically we have an amazing, again, BC, the BC building code has an exceptional compliance pathway. It's an optional compliance pathway called the BC step code. And thank you for pulling that up. So what this means is this is more in relations to new homes, to be clear. And what this says is that we are aiming to have all houses fully net zero ready by 2032. That is a remarkable target and goal. It is not aspirational, feels like it is, but people are already getting there. It is, and this is, if you can visualize this, every house is going to be essentially, well, we can break this chart down in a sec, but if every house becomes a step 5 net zero ready house, that's going to be a house that uses 50 to 80% less energy. That's an incredible reduction in demand for power. If you think about it, that's going to be required code. So this is not like a sort of like, let's hope to do this. This is going to happen by 2032. So that last 20%, the idea of net zero ready is that remaining 20% that you have to come up with, you're going to be able to generate it from an on-site renewable system, like a solar system, for instance, is most popular. Wind is a bit trickier. It's an option, but you usually need it up pretty high to get above the effects of the trees. So solar is a really popular front runner on that. And there's other systems as well. But yeah, look, you can see the numbers here. People that live in regular homes, those are called Part 9 buildings. They are, if in the column here, we're looking at a chart. The green text shows the Part 9 buildings and the step codes. So a BC step code, again, we're sort of diving in here on a bunch of content, but this BC step code is a 5-step process. A step 1 house is essentially a house built to the existing building code. And then a step 2 house, 10% better than that. Step 3, you'll see in the orange, is a 20% better. Step 4, in the orange, again, on the right-hand side, is 40% better energy use. And then the last step, step 5, in the green there, is up to 80% better in reducing your energy use. So you can see by 20, these are mandatory timelines. On the left column, it says 2022. That's next year. That's going to mean that any new house has to be a step 3 house. It has to be 20% better. So that's a great start. And I can tell you for myself, we are already hitting lots of step 3 houses. It is not a problem to hit step 3 with very little changes with a diligent builder. Step 4 is required, mandatory by 2027. And some of our municipalities are adopting these step codes. They're allowed to do it faster than this prescripted pathway. So for instance, Pemberton is incredible. North Vancouver is incredible. There's some serious places that are requiring now step 4 and step 5 buildings already. We're just skipping over the first bunch and we're going right there. And the people in those communities have municipalities, and reach out to your municipality and your councillors and say, we want to adopt this step code, and we want to talk to our builders, and we want to talk about an accelerated timeline to get this in, because we want better, healthier homes that use less energy and have less pollution. So the quicker you can, adopt this system, the better. So that's one thing. And as a baseline, we have this compliance pathway that's going to be required through the province.
So big picture, in 10 years, any new home in BC is going to be built to a totally different standard. Where do you see this going, and why is it important for owners of existing homes to catch up?
Yeah, it's a really interesting situation. It's like, I think there's a phenomenon called the Osborne Effect, where when you think something better is coming out, you don't buy it. I think there's a famous story. I think it's Mr. Osborne, probably, back in the 80s when he came up with a pretty amazing supercomputer, and it was pretty much, it was like early 80s, I'm pretty sure. And it came out, it was amazingly popular. It was going like gangbusters. And they said, oh, wait till you see what happens next year. We have an amazing model. And that comment pretty much made everyone stop buying the one that was out in the market and wait and buy the next one. And that torpedoed, actually bankrupt that company. So it's a happy story. Not really. So, but I feel like the step code is going to create a little bit of that effect where people know there's step 3 houses out there, step 4 houses, step 5. They're going to want one that's high up the code. And so this is going to create I think a market setting where people want these upper step level houses that cost less money to operate, that have HRVs that ventilate the house with all beautiful fresh air, and they're healthy and durable, and they're just comfortable to live in. So what's gonna happen is with our existing stock is that if you're not upgrading and renovating your homes, you're gonna sort of fall behind where the new ones are at. So fortunately, as we come back to the EnerGuide program again, this is a really great program from EnerGuide because it's basically getting all the existing housing to assess its status and then get it caught up. And a lot of the catch-ups can happen with, just strategic updates of mechanical systems without big changes. And other systems, you got to work on long-term plans to upgrade walls or outer insulation or what have you. So yeah, it's just important from a market perspective because the quality of housing is going to be going way up. It's been more probably advancement in the demand. Our builders are under a lot of pressure right now to basically meet these targets. So they need people out there helping them. Energy advisors like myself are just, running all sorts of scenarios and getting these guys the best, most affordable way to climb that code and get people the best houses we can get with the budget. So it's an exciting time, like the more innovation in the housing sector right now than there has been in the last 10 years than there has been in the last 50, I think I hear people say. So it's a pretty exciting time and good news for abating climate risk with energy efficient homes and then decarbonizing them as well.
So we'll get into some of the changes that people can make who own those older homes and who are going to be competing against these fancy new homes in the future. But first, I want to share the results of our first little Zoom survey. If Jamie, we do have results from that, we can put that up. So we asked, what parts of your home are you interested in upgrading? And 44% said insulation, doors and windows. 61% are interested in upgrading their heating system, and then 43% for hot water system. Another 35% interested in updating their appliances, and 57% of people said they want to look at solar in terms of energy generation, which you mentioned, Ryder. So lots of interest here, and then almost 30% are thinking about a vehicle as well, which could also be used as a backup power source in the future if you have a big battery car in the garage. So lots of appetite there, lots of interest for upgrading, but obviously the big one on most people's minds is the heating system. So you were talking earlier, Ryder, about the way the world has changed in terms of sort of accepting limits on carbon, and there's a few newspaper columnists and at least one political party federally that might be dragging their heels on this. But overall, the world has accepted that we're not going to be digging up black stuff and lighting it on fire for much longer. And the debate now is how to phase it out and how quickly and where to focus on first. So what is the larger implication of that shift, do you think, for BC?
Yeah, it's a great question. It's funny. It's like you said, we have a love-hate relationship with fire and burning things. We've gone through a tremendous amount of success burning things for our energy. So we're evolving from the species of where we used to burn stuff for energy to a species that generates the electricity in a more elegant fashion, which lately has uses things like compression and various other technologies to get the energy that we need, and actually often not even creating it, but shifting it, transferring it from one area to another, like a heat pump does. Right. That's the funny part.
We'll get into heat pumps and how they work in a minute.
So yeah. Basically the situation is this: everyone is now on board with this ability. We need to get this carbon under control, this pollution under control, and we are looking down the pipe of $170 a ton, on carbon taxation, and trying to meet our Paris target commitments, and 2030. So there's let's pull this table up here. You can see that what's happening. We froze the BC's carbon tax rate at about $40 a ton because of COVID, but it's going to have to catch up and harmonize with Canada's carbon tax. So it's going to go up. It's been going up $5 or here or there, but starting in 2022 we go to 50, and just up to harmonize with Canada's carbon tax, and we have to basically move at $15 an increase every year thereafter. So it's going to be accelerating. So at the top there, you can see right now, for instance, at $40 a ton, carbon tax is adding, I think, about 7.6 cents or 8 cents a cubic meter of natural gas. And it's a bit nebulous how that sort of plays out. And that applies to all, every fossil does have a tax associated with it. So these are sort of market challenges that gas faces through this transition period. And as we go down the table, you can see there's a lot. There's more increase coming. So essentially, there'll be about 4 times the tax rates that there are now. And I don't know how that all sort of plays out. And things could change because we keep evolving our tax policy. So, but I think what we do have is a notion that in a carbon constrained world, you have a limited amount of this material you can put out. So that starts to increase and ratchet up the pressures and the risk that carbon taxation can increase if things aren't going as well as we'd like, because there's more urgency to remove it. So what you have to do is look at your systems in your house and understand what kind of carbon taxation risks you are exposed to. What kind of systems are you using? How are you, if it's a new home, how are you going to build your house? What kind of materials are you going to use, and what kind of embodied carbon are they drawing down? We can touch on that. I'll touch on the whole embodied carbon thing and upfront carbon thing afterwards, because it's pertaining to building new houses and how we extract and manufacture and ship all these house parts to make houses. That's a little different. And then there's the operational side of housing, which I think people with existing homes now, that's how they can make their big effect, is looking at their operations of their house and what the carbon footprint is of it. So, what we have is basically, people talk about this being an environmental problem, but it's really a financial one. Essentially society needs to remove its financial carbon taxation risks, and people need to do the same with their homes. That's really important. So we've seen this with the city of Vancouver, the Greenest City Action Plan, and with the latest 2019 building bylaw. There's certain types of residential buildings now have put in place very stringent regulations around carbon emissions that are allowed per buildable square foot. So they call that your greenhouse gas intensities. And so they have limits to that. And that is, as I see it, and sort of where it's going, you're gonna have limits to the type of systems you can use after January 2022, which I think will favor predominantly heat pump use. Will be the only one with a low enough GHGI. I haven't looked completely deeply into it. That seems to be what it looks like on the numbers side. So there's going to be some variation. This isn't talking about for appliances. This, it's likely to continue to be gas use in appliances and things. But the space and water heating is where you have 94% of your carbon pollution, right? So those are big systems. And other cities like San Francisco are following the lead there and doing similar kind of setups to work on cutting their carbon in their cities. So there's a lot of pressure on everybody right now.
Big picture, we have agreed to phase out fossil fuel use as a society. And so the government has started to use tools like taxation and regulation in order to disincentivize fossil fuel use. And because they've opened that door, we're going to be paying more for natural gas in the future. And there may be some technologies that are simply phased out or banned. And so for people who are still running on these systems, there's not just a health consideration and a greenhouse gas consideration. There's also the financial impact, as you mentioned, through taxation and through just the cost of operating. So I want to get into heat pumps because that's what you mentioned. The BC government is encouraging people right now to switch over from oil burning and natural gas burning furnaces to electric heat pumps. Can we just explain what a heat pump is? I'll bring up a picture here. We're looking at, it looks like an air conditioner unit on the outside of a house in winter. What is a heat pump?
Yeah, and they're kind of these bizarre, mysterious boxes you see on people's houses now. That's what they are. And but yeah, they essentially are really they have a compression tool outside. Essentially, they transfer heat from outside to, then they run it through into some refrigerant, fluid, and that fluid runs into the house. That fluid's heated up when it gets compressed outside. And believe it or not, you're extracting heat from the air. Even you can do that in below minus temperatures because you're using a refrigerant that has a different sort of set of properties than air or water. So it's hard to conceptualize, but we now have cold climate heat pumps that can pull basically warm refrigerant up by compressing outside air essentially, and running your refrigerant lines through it. So essentially you're transferring warm refrigerant to the inside, and it's running to either an air handler in a furnace, and then that's blowing and then there's another coil over there that's allowing the air to pass over that coil and transferring the heat into the duct system. If it's a mini split, it's going to an internal head with some those warm sort of refrigerant coils or lines, and their fan is blowing air over them, blowing warm air into the house. And simply put, if you're air conditioning your house, which is one of the great benefits of heat pump, as you know, and especially in a resilience level, as you realize that we have a warming climate, having a cooling system built in automatically as a part of your system is just like one of the biggest sort of positive attributes, obviously, of a heat pump. And a lot of people hear the word heat pump, they forget what's actually cool pump. But right. The system runs in reverse for cooling. So that's how it all kind of goes.
So in the winter, you're generating heat from the warmth that's captured in the air outside. Even if it's below zero, there's still some energy in that air. And in the summer, you're doing it in the reverse. You're dumping heat from inside your house and you're pulling in and cooling air, which is great for, as you say, rising temperatures, especially people who are older, who have some health conditions. Heat can be really, really hard on people's health. And we're going to see that more and more. Plus, you get the added benefit of filtration, right? So better indoor air quality with most heat pump units, as I understand. So the government's offering these rebates right now on heat pumps. Why are they giving money away?
Well, they have some pretty demanding targets to hit here, and I don't think we're moving quite quick enough at all. And they realize that, and they are putting the requirements to put these heat pumps in, because when they run the numbers on these heat pumps, looking at Clean BC's website here, where they ran some numbers here. I was looking at them a couple days ago, and they project that the heat pump uses, I believe, 97% or produces 97% less carbon emissions. So we're talking about decarbonization today. That becomes a pretty compelling option for somebody who's interested in deep decarbonization of their home, is looking at an electric heat pump, which according to this site will offer tremendous cuts to your greenhouse gas outputs on your house. So the government is incentivizing this right now. It's a pretty sweet deal. It's a double the rebate. It is limited to people with fossil-based systems, so the double the rebate only applies to people that are fuel switching. So they're trying to encourage fuel switching from a fossil system to electric system. So that's one thing to keep in mind. They do, however, offer this double the rebate for people that want a heat pump hot water heater. And if they're on an electric system, that is still up for grabs. So if you think you're going to update your hot water tank, and I can tell you from having seen the bunch of houses I've done, a lot of people asking about them. They're super popular out east, and they're brand new sort of technology out west here, and people are just learning about them. But in the last 3 houses I did, we saved over 10 gigajoules a year just by upgrading a conventional electric tank to basically a heat pump hot water tank. And to be honest, it's a new technology, and the one limitation is you got to find someone who knows how to put them in. So there's a higher cost associated with them. So there's some logistics to work out, and places you're going to put them. They like to be indoors, like above 2.5 degrees and that kind of thing. So you typically have them in a mechanical room versus maybe out in a garage.
Right.
But they are hybrids, for instance, and you can talk about, it's another topic in itself, but I won't get into that one.
But the important thing to realize here is that heat pump technology, it uses way less electricity than like a electric baseboard or electric radiator, right? Like, because it's compressing and expanding refrigerant, it's not actually just like a toaster releasing that radiant energy from coils into your home. So that's why they're so much more efficient and cheap to run than like a regular electric baseboard. And the same technology can be used to warm up water as well. You could take energy out of the air and run that through coils and use that to warm up water, right? So we're looking at a Clean BC brochure that they mailed out, where they're promoting the energy savings and the money savings with heat pumps. And yeah, you can see how they're marketing this to the public. Stay cozy, save money, switch now. But there's something on the back here that we wanted to highlight, which is that as you mentioned, most heat pumps produce 97% less greenhouse gas emissions than even a high efficiency natural gas furnace. So that's a great plus for people who are looking to cut their own carbon emissions and fossil fuel use at home. And there's this double the rebate. So can you just tell folks quickly about how they can claim this enormous rebate? Because if you go with both a heat pump and a hot water tank that runs on the same technology, they're offering up to $8,300 right now.
Yeah, it's pretty incredible. And I'm sorry, I got off a little off target on that last session, but I should point out that a heat pump is generally, getting to be 300 to 400% more efficient on energy. So it's 1 unit of energy in, 4 energy units out. So that's where they become so competitive, because sorry, I didn't mention that. But to get these rebates, basically you just have to go to the Clean BC website. One of the big bars at the top says apply for the double the rebate. So get in there. You have to pre-qualify, which means you got to be a client of Fortis or Hydro, and you got to basically have a history of energy use there that they can look at and make sure that you believe it or not, if you don't use enough energy in some very low profiles, you might not be able to get this rebate. And you have to in this particular rebate, they want to see someone who's on a fossil-based system. that's upgrading because it's a fuel switching thing. Except for the heat pump hot water heater, they will take people that are on electric systems. So go to Clean BC's website and apply. And you shouldn't need an energy advisor for this. You can just go and get the basically go ahead and get registered for this promo. You don't have to use it. It's free to sign up, and you have till March 31st to do it, and you have till June 31st to get the work done. So just sign up for it for now, and then make the plan after or don't use the offer. But it's a pretty compelling offer in my town where I am. If you do this fuel switching from maybe a natural gas system to a heat pump, you can get like 3,000 for a heat pump, and that's doubled. That's $6,000. The local region offering it. The Comox Valley Regional District is doing a $2,000 top up, which is kind of special. Wow. So it's $8,000 you're getting off this system now. That's, it's really making it attainable. And if you're in a position of, if you're fuel switching, there's also some zero interest loans you can get for this system under certain conditions, which may or may not apply to people. So they should check out that. So just go to the Clean BC website, apply for the double the rebate, and then go down the list and just have a look at the rebates that are there. Search and you just put in the name of your town or your regional district, and if you're either renovating or if you're building new, because the rebates are totally different packages. I'm talking about existing homes right now.
Okay. So that's great to know. And municipalities offering those top ups is really helpful because you can save even more money right now. I'm just looking at a couple of questions in the chat. So the reason why they're offering this limited time sort of double the rebate is because of COVID. It's an economic stimulus measure. So the BC government upped the rebates in order to try to get more renovations happening and stimulate more activity in the building sector and get more HVAC installers and energy advisors working. And we have another comment from somebody here who says we just replaced our furnace with natural gas because that was the wisdom. So there are folks who would argue that if you're just trying to increase efficiency and reduce GHGs, that you would just sort of replace an old gas furnace with a more efficient gas-based system. What advice do you have for people who are at that crossroads right now, who are looking at upgrading their home heating system? Yeah,
that's a great question, and it's lots of material out there to know, and it's hard to know the path. I encourage everyone to choose their own path and just go with what is affordable for you in your budget and what feels right. Look at what you're asked. Talk to your partner about, or if you live by yourself, you can talk to yourself. About the type of things you want to get out of a home, home improvement. If you don't know what to do, but you think you want to do something, that's the perfect place for an energy advisor. Someone like myself, you call us in, we do an assessment, we rate sort of the energy performance of your house as it is. And then we'll come up with an energy efficiency roadmap. And what we'll do is we map out all the top heat losses in the house. And then we go after all the top energy users in the house. And the idea is to tackle both sectors, together. And then what we can do is we do also what's called the renovation upgrade report. And then we project, we say, okay, what kind of upgrade are you thinking? He's like, well, I want to go from a low efficiency gas to a high efficiency gas. Okay, I can put that in, and with the specs, we can look at it and see how much you're going to save in money and in carbon. So that's an option for you if you're into using your gas system.
So I've brought
this
up
is a chart here.
Yeah. You made this chart, right?
This comes from ZebX's website, the data, and they actually got the data. I thought it was interesting from the Integral Group's 2019 study on the effects of the step code on carbon output on homes. It's quite a good study. Lots of neat numbers in there. So I kind of three popped out at me. So in the three, this is for new house scenarios, just so everyone knows we're talking about looking at step 1 houses, which are code level houses, step 5, which is again 50 to 80% less energy. So top of the code is step 5, bottom is step 1. Let's say that. So I took a step 1 house with an older. This is again using all the numbers in the integral report. So this is just their numbers. But this step 1 house in their diagram, it comes out to, with the natural gas, older kind of natural gas system, about 2,900, I believe, 20 kilograms of CO2 equivalent put out per year. Now, if you decided you wanted to upgrade your building envelope and make that house very efficient, cut down the air loss and get some more insulation on there and elevate that house to a step 5, you can see that there's about a 70% drop in your carbon output there and that's using basically a step 5 house with a high efficiency sort of natural gas stove. So that's a compelling drop. So that's one step. Now in the last column, that takes it down to about I think it was about 700 or 800 kilograms of CO2, equivalent per year. And now if you take that step 5 house and you instead just move it to an electric heat pump, it drops way down 7 more times from the second tier to about, I think it was 128. I should have wrote the numbers on there. Kilograms of CO2 equivalent per year. So it kind of just shows you there's many different ways to reduce your carbon, and you can see what does, the key things to keep in mind. You can improve your building envelope. It's kind of like, let's get the house envelope under control so we stop the heat loss. That's the big thing. And let's make our mechanical systems more efficient. And you can see there the tiers, where the highest tiers are for carbon reduction potential, again, sort of lies with the technology again, with in this example with the heat pump.
Okay. I think we're going to open it up and get into some questions from the audience, because we've got lots of questions popping up in the chat and the Q&A. So make sure to toss your questions in the Q&A there. But here's a quick one. How much does an energy assessment cost?
Yeah, no, it's a good question. Generally, there's quite a lot of energy advisors out there, and essentially the Natural Resource Canada has like an administrative network of people doing this, consultants like myself that aren't actually part of the government. We're private consultants doing work as a part of their administrative network. So the prices vary by region and by house size. So a 3,000 square foot house, with complicated basement setup and half above ground, half below, there's all sorts of heat loss weird things. You might be in the $700 range, and with a smaller house you might be in the $500 range. I would say it's probably kind of a zone you're looking at, and then you're going to get rebates on those. So in my area, it's 200 rebate from Clean BC and 150 from the regional government top up. And again, you can see all your rebates on Clean BC. So just get a few quotes, call around a few EAs in your area, and then you get an idea of sort of what you're looking at. But what I get feedback from everybody is, wow, these like energy efficiency reports, the homeowner inspection reports that come out that give this like energy efficiency roadmap are just so illuminating on what's happening in your house and so helpful that it really provides some reassurance as to what you should bother spending money on, because you might have an idea to do one thing, like for instance, you might want to put solar on your house, but you've got like a major leakage going on in one spot. So you might just want to quickly fix that first, then go to the solar. So yeah, so just if you're not sure what to do, definitely and having an EAN will just be a great help. And yeah, so.
Right. Another quick question here from Maria Teresa saying, any tips for gas fireplaces, how to reduce emissions and energy use from gas fireplaces?
Yeah, it's funny. Go to a website called EnerChoice. They rank gas fireplaces on their efficiency. And it's a BC website meant to kind of help people navigate them, because to be honest, gas fireplaces are usually very inefficient. They range anywhere from 55% efficiency to some of the new ones now I think are getting up into close to 78 or 80%. That's compared with like, say, a natural gas condensing furnace, which can be 98% effective, and then a heat pump that's 200 to 300% effective. So you kind of get a sense is if you're going to be using a gas fireplace, that's the kind of thing you don't want to be using as a primary heat source, because you're going to be heating your house on let's say 75% efficient tool versus something that's, either 98% effective and if it's a gas one, or 300% effective if it's a heat pump. So the best things you can do is, if you have no option to change that out, is to check your blower in there and make sure it's blowing air out of it, and that you have a vent at the top of it that goes up to the ceiling and can hit the ceiling and lets the warm air out and let it recirculate along the ceiling and kind of create this circulation of air. So make sure that warm air is getting out of there and going out into your room appropriately. But again, the tip is to, obviously use your primary system first. Another option, of course, is you can upgrade to an electric furnaces, which are absolutely crazy now. You get Bluetooth in them in every color you want, and there's on-demand fireplaces that are electric that you don't have to even turn on the heat. You can just have the visuals. So you can put on your sweater with the skier on it and play the guitar and have some juicy fruit and put on Bluetooth flames if you want. It's the electric fireplaces are really compelling if you want that option out there. That exists
like
too.
the Christmas Yule log channel all year round.
Yeah.
So a couple other quick questions. We had a complaint or two from folks who have older heat pump units that they installed in past decades. And a question from Laura here: Are they noisy? Are heat pumps noisy like air conditioners?
You know what? Noise is it's funny. It's probably the one thing I find people talk about. One disadvantage with heat pumps is there's the older units where noisy, a lot of them are, and that's a legitimate thing to be aware of. You want to look when you buy a heat pump. I would encourage you to ask for the decibel specs on them, the noise specs. And a dishwasher is about 49 dB. That just lightly cooks away while you watch the Golden Girls, right? And then that's not barely noticeable. A human voice is about 65 dB. So you want to make sure your heat pump is turning in that upper 40s or lower 50s zone. So this stuff's all measurable now. You just make sure if you're getting them scoped, you're getting a quiet unit, because there's some really quiet ones out there, and there's a few relics that sound like there's people sticking metal into the blades or something. So you definitely want to just have a look at what you're getting
right.
Lined up for sure.
Another question about heat pumps. Do they work well at -10? There's somebody in the chat here who says, I've had HVAC contractors advise against them. And of course, different parts of BC, the negative temperatures get down pretty far in the winter. So -10, most parts of BC, would a heat pump work?
Absolutely. No problem. They would laugh in the face of that -10 if it were a person. It is not a problem. You just, there's a website dedicated to what's called a cold climate heat pump. They're called Northeastern Energy Partnership, the NEAP website. I can give that to you, Kai.
Yeah, and we'll send it out after.
And it gives tons of specs on these things. You can pick. There is a whole bunch of cold climate heat pumps now, but you have to ask for a cold climate heat pump. I'm in a more moderate area. I just walk around in shorts and in a jean cutoff shirt, pretty much. It's so warm down here, and that's a good picture for all you people at home. And then, but I know that the Northerners on Ambourne Terrace, they have a little bit more of a demanding situation with temperature, so you want a good cold climate heat pump, but they'll work great. I talked to a lady who moved from the Skeena River. She had a beautiful house on the river up there, and foxes nesting on the land. It was sounded amazing, and she was running a mini split, 2 heads on her house there, and it was totally warm, and she loved it. She just moved down to the island, but it's fully doable now. Again, you want to look at the usual stuff. Just look at the COP, the coefficient of performance, and that's the heating season performance factor. You want to look at 2 factors: HFPF, the heating season performance factor for the heat pump. Make sure it's high enough to get the best rebates, and you're also going to look at the SEER value, which is basically your cooling efficiency, and that number is going to be around over 16. The HSPF is going to be over 9.3. Once you be above those, you want to ask your provider, your contractor, get some quotes. Say, I want a cold climate unit. I want it to be quiet, so it's not too loud. So I'd like to know what the dB specs are on it, decibel specs, and I would like to, the HSPF and the SEER performance to be meeting that tier 2 rebate requirement.
Okay. A couple of questions about condominiums. So Stephen asks, he says, my wife is the president of our strata council. We're interested in reducing our environmental footprint. Can you recommend a good resource for how to do this in condominium buildings?
How many units are in the condominium?
We can see if Stephen answers in the chat. We have another one from somebody who's anonymous who says, I live in a condominium unit with 24 units. Wondering if we can get an efficiency assessment done on our building and if there's any rebates for upgrades for us. So what about people who live in condos?
Well, yeah, there's absolutely some options coming out now, and so I would encourage you to look at a couple things. One is, the heat pump situation, if that's what you're interested in, for its low carbon options. There's a company in Vancouver called, oh my God, Small Planet Supply. And they sell high performance home equipment. You want to make them a regular on your call list. They got lots of great stuff going on there. I use them regularly. They have a new sanding system that they're setting up, where they daisy chain them, and they're basically a really cool heat pump situation where they for multi-use residential buildings. So I would call them and ask about that. And it's called the Sandin CO2 system, and it actually uses CO2 as a refrigerant, which has a global warming, it sounds terrible, a potential of 1, and that is actually extremely low compared to the refrigerants that are typically used in heat pumps. So, which are probably in the 1500 range and up. So it's a really great environmentally friendly option to look into. And so, yeah, give Small Planet a supply and see what they have to say. That'd be a good one. And other than that, there is quite a few heat pumps emerging that are running hydronic floor setups, but in a condo, I suspect it's just space and water heating normally in the air, not through hydronics. So yeah, try it. I would recommend giving that a call.
Okay, so I'll collect some of these links from Rider afterwards, and we'll send them out to everybody who RSVP'd. So you have all these websites and resources at your fingertips. We do have Rider for a few more minutes, so we're going to get into some more questions, but I wanted to bring up one more little survey for you. And that's because we have a couple of people asking about scaling this up. They're talking about doing this at a larger scale. One person in the Q&A asking, how can we convince new large buildings like schools and hospitals to use renewable energy sources instead of fossil fuels, especially since as the taxpayers, we're the ones who are going to be paying the fuel bill for those buildings for decades to come. So we have local teams in different regions around BC, part of our local power campaign, who are working to scale up these decarbonization efforts at the household level, but also at the community level. So if you're interested in joining with other like-minded folks in your part of BC, you can pop your answer into this survey. We'll leave it up for a few minutes here. And we can get in touch with you if you want to connect with other people in your part of the world who are tackling this challenge as well. So we'll leave that up and we'll get into a couple of more questions. One from Carla, which is interesting. She says, if we insulate all our windows and doors to the point of not getting enough fresh air, especially in older houses, where's the benefit in that? And what's the balance between air circulation and bringing oxygen into your house and being super efficient and airtight?
Yeah. So if I understand that question, was what is the purpose of increasing ventilation if you're trying to make it airtight?
Well, she's asking about the downsides of making the home completely airtight. She's worried about getting enough fresh air.
Yeah. Okay. So this is a great question, actually. And I've run into this with the builders too. A lot of older builders that are used to certain ways of operating, but and what I found is that a lot of people say a house has to breathe, but there's some interpretation there. Are we talking about breathing through the walls, or are we talking about breathing into the air in the house? So they're kind of half right in that statement. One is the house does want to have fresh air inside of it. What it does not want to have is the walls breathing, because what people feel that might dry out the walls. But the conventional wisdom, which has been put forward, by founders of building science, if you look at the Building Science Corporation, says that 99% of your water movement is with air. So if you're moving air through your walls, you're offering 98% of the water supply for that wall. So what you want to do is you want to build an airtight wall to keep the air out that's vapor open. And you can do that now with like the sheathing membranes and materials. So if the air barrier keeps the air out, and thus the 99% portion of water that's getting into your wall. And if some does get in through a bulk water leak, your walls are vapor open, so they're allowed to get let vapor and water escape. It's very cool building science stuff now that people are realizing, and they're building buildings now that respect some of these basic tenets. So, so to answer your question, you want to have air purposefully brought in with a mechanical and ventilation tool like an HRV that's going to deliver fresh, good air. We always spend, now I think it's 85% of our life in our house. It's actually crazy that we don't spend more time understanding all this information and all this situation we're sitting in all day long. So an HRV is this amazing ventilation tool that is intentional. And instead of getting your house to leak through all the walls and joints and old drywall and dirty insulation, you're bringing it in through a clean air vent and the fresh air supply in, and then you're exhausting that air through the same heat exchanger tool called the HRV. It's a box with 2 fans blowing air different directions across a heat exchanger. That fresh air goes in the house, gets through the heat exchanger, gets warmed up by all the air, the warm air leaving. This is like in the winter. And then you could get this nice warm air coming in, it's fresh. And you can change your house air many times per day. So it's great for your health. And if you have air quality issues, pets or allergies or allergens, stuff like that, you can use filters and because it's called an intentional ventilation, not an accidental ventilation through leaks in your house. So I don't know if that answers your question, but you definitely want to have lots of airflow in your house, and you just want to do it through intentional openings like an HRV.
Right. Couple questions about the building code. Karen asks, what does net zero ready mean in the step code?
Yeah, it's actually a great interpretation. So it's a great question because there are certain focuses depending on who you talk to, but essentially it means that the net zero ready is a highly efficient house. In our case, it's step 5, 50 to 80% less energy use. And that remaining 20% of the energy that runs your house is delivered by renewable sources on site. So it would be, a solar system. And typically you can have, because we're grid tied in BC, we have this very fortunate setup. We have a buyer for your power. So that's BC Hydro. So if you overproduce on your solar in the summer when you don't need it, the grid buys it back. It's usually what happens if you have a good system. And then in the winter, and then over the summer months, you build up a credit. And then over the winter, when you're producing less sun, less power from the sun, you're using that financial credits from the summer. So if you build the right size system and your house is efficient, you're going to have like a zero energy bill at the end of the year. It's pretty incredible. So net zero ready, that's what it means. You can have, gas systems in the houses, but maybe it's for a stove or something, but typically it doesn't work super smoothly because there's a lot of the net zero ready guidelines and now have a greenhouse gas intensity limit, a GHGI intensity limit. So you have to have a low intensity number, I don't know, below 5 or 6, equivalent, kilograms of CO2 per area, so it's going to probably be driving you towards a heat pump. And then the second thing is that on a net metering system, if you're generating power, you can't sell the gas back to the grid if you have extra gas. So if you overproduce on your solar, because you're powering part of your house with the gas, you're kind of double paying for it. Just the gas doesn't sort of mesh very well with the net metering program, how it buys power from you. So that tends to be what happens as you go up. You tend to increase your electrification component.
There's another question here from Karen that I think is interesting. If we're switching over houses to electric heat pumps and people are switching out to electric vehicles and electricity consumption increases, won't this result in the need for more dams? She says Site C is not an environmentally friendly alternative, in my opinion. I'd agree with that. Where do you see things going in terms of energy consumption overall as people switch over and electrify their home systems?
Well, I actually kind of love that question because to me, I find this question comes up a lot. And there's a great notion that electrification is going to cause the need for all these big structures. But visualize this. Every car is sitting on all the electric cars now that are exploding are sitting on 45 kilowatt hours of batteries. That's about like a car with 3 Tesla Powerwalls strapped onto the back of it with some bungee cords. It's an incredible amount of power. So we drive like 10 minutes to work, and then most of your battery doesn't get used. So what you can do now, what's going to happen, now we're getting the future of the market. What's happening, people are going to drive their electric cars home and they're going to plug it into the house. There's going to be a vehicle to grid charger. Your house, you'll be able to charge your car with if you have power because you're on grid. And if the power goes down, guess what? You're going to plug your house in and using a smart panel, you're going to use the car's battery, power your house, and you'll use the panel that systemizes and picks like only the systems that you need to run during that outage to keep the fridges cold so the food doesn't spoil, to maybe run a recirculating fan on the heater. And like your heat pumps are going to draw a little energy, so maybe you'll tune those down and use those a bit. So That's pretty incredible. And then when your battery gets low, you drive it down to this downtown where there's, backup something power, if there is any, and you can charge up there. Most outage days in my area are 2 days per year, and that's going to be easily covered by a battery in a car, if you have your systems in your house dialed. So I don't see a demand at all. In fact, if when you brought up Site C, when they were looking at the, I believe it was the initial panel for the review, all the documentation shows that demand is dropping and it's continuing to drop. So what's going to happen too is that the solar curve, as more distributed energy comes into the grid, all these houses will become power plants. They'll use the cars, batteries, and the house generation facility on the roofs, essentially develop virtual grids versus distributed energy power. Those are going to augment any sort of shortfalls once we start doing this. So the smart utilities right now, and I'm looking around North America, are actually turning this distributed energy, they're internalizing it as a profit. They're looking at buying the panels themselves and putting on people's roofs and using that profit for themselves and realizing, holy cow, look at all the empty roof space out there. I could actually be generating my money off these without expensive infrastructure projects that are socially, environmentally, financially very challenging to pull off now. We've seen this on all of our big projects lately. It's just a nightmare, it feels like. Imagine everybody just basically producing their own power. And then, so if the net zero philosophy is embraced, which it is coming, it's in our building code. It's the philosophy of being net zero, is using what you have, creating what you need on site. We're going to see a diminishment of the need for these large generation facilities. And what's going to happen is utilities are going to move from power generation into power distribution. And so they're going to become distribution experts. The grids are going to get super high tech, and they're going to basically use a more elegant sort of network, ganglion, and power sources that are locally available. So it's all happening. That's happening now. Like, that's going on, and progressive utilities are seeing it, and they're just jumping on it. That's just what's going to happen. So we have like we have a good network of hydro here that we have, and that will become a part of it, what we have. But in terms of building new stuff, it's not going to be needed, in my opinion, because all of these other power sources are coming online, and there's plenty of examples around in Australia with the Hornsdale Reserve, and with all the stuff in the northeastern states that's going on with some of the providers there, the utilities there that are, basically setting up all these massive virtual grids of people using people's houses, thousands of them. So it's pretty neat stuff. So I'm not worried about the electric car stuff at all.
We're going to use less energy. We're going to use fewer joules. That's the other thing, right? Is as we move to more efficient buildings and vehicles and space heating and water heating, we're going to use less energy overall, and that makes it easier to generate that at home and break even. So yeah, we're going to have to leave it there. I really want to thank you for your time, Ryder. There's a bunch of questions that we didn't get to, so we're going to do a couple things here. We'll bring up the results from the last survey, so you can see how many of your friends and neighbors are interested in connecting with local power teams. So you can see there's 32% of people are already on a Dogwood local power team or are interested in joining one. So that's great. Bunch of new volunteer hand raisers today. There's another 24 people who say they want to know more. So we'll get in touch with you and give you more info about our local power teams. And for the folks who weren't able to get their question answered, because we just only had an hour, and we got to let Ryder go. He's got a business to run and a life to get back to. We're going to put his contact info up here with his permission, so that you can get in touch directly, especially if you're in the Comox Valley. But if you have a general question, or Ryder can help you connect with the resources that you're looking for, we'll put his contact info up here, and we'll send out an email afterwards with links to some of the resources that we discussed in the workshop. We have a nice 2-page PDF that connects you to all of the rebates that are available right now throughout BC for both homes and for transportation. And we'll connect you with the campaigns in your part of the world to scale this up and take this from a household level to a community level as we fight to decarbonize the province over the next 10 years. So I want to thank everybody for joining us. I did want to put in a plug for the events that we've got coming up in the next couple of weeks. So next Tuesday, March 30th, we'll have Dr. Melissa Lem joining us to talk about the hidden health hazards of natural gas. April 13th, we'll be talking about scaling up our decarbonization efforts with Karen Tam Wu from Pembina. And on April 20th, we'll be doing a special collaboration with Raven Trust and Chief Roland Wilson from the West Moberly First Nation to hear about the latest chapter in the Site C fight. And there's lots of questions today about Site C, so you'll be able to get an update then in just a couple of weeks. So those are the events that we've got coming up. Ryder, is there anything else you want to plug or mention before we sign off?
No, I think I'd just like to say thanks for everyone listening in today, and Kai, for you guys, working on these creative kind of solutions. I feel like make a house that you love and you feel good about. And, what you guys are talking about today and promoting, this decarbonization stuff will give people that feeling, and that's what people need right now, is good hope and a real ability to understand they can have a big difference with their house and have a healthier, more durable home for it. So go out there and get her done.
Get her done. All right.
Yeah.
Words to live by. Thank you so much, everybody. We're going to say goodbye for now. Talk to you later.
Okay. Cheers, Kai. Thanks.
Thanks, Ryder.